So good morning, Year 7. Today's third lesson for our geography topic is all about what the crust is and what makes up the structure of the Earth. So, you might have been told that the Earth is spherical, but this actually isn't quite true. Instead, the Earth is a different sort of shape called an oblate spheroid. What this means is that despite its spherical shape, the Earth is flattened at both the North and the South Pole and bulges around the equator, around the middle of the Earth, so it's not a perfect sphere. So the structure of the Earth is made up of four distinct parts, and the first part is the crust, and this is the thinnest layer, and it can reach between 25 to 70 kilometres in thickness. The crust itself is divided into large chunks known as tectonic plates, which float on top of the mantle, which is our second section of the structure of the Earth. So the crust is the top layer, and this is the layer that we live on. So the continental crust, which are the bits that form over land, these are thin parts of the crust, and these are very, very light, and they are made up of rocks, and they're not very dense. The other part of the crust is the oceanic crust, and this is the part that sits above the ocean, or sits beneath the ocean, should I say. It's between 6 to 11 kilometres in thickness, and it is very, very heavy, and it's very, very dense, and it covers approximately 2/3 of the Earth's surface. So the crust is our most outer layer. Our next layer is the mantle. The mantle is the thickest layer of the Earth, and as you can see when you look at the PowerPoint for yourselves on our diagram, the crust is very, very thin, and then this bit right here is the mantle. So it is approximately 2,900 kilometres in thickness and forms about 80% of the entire Earth. The mantle is liquid and is divided into two parts, which is the upper and the lower mantle. And the heat within these layers creates something called convection currents, which we'll come on to later in the lesson. Our third bit is the core, and it is divided into two parts. You have the outer core. So this is a liquid of is at a very, very high temperature of between 3,500 to 4,000 degrees Celsius, and this is what creates the Earth's magnetic field. Heat from the core powers those convection currents, which I'll come into shortly, and it's approximately 2,600 kilometres in thickness. Our final part is the inner core, which forms the centre of our Earth, and this is the hottest part of our planet. Temperatures in the inner core reach between 4,000 to 4,700 degrees Celsius, and it is as hot as the surface of the Sun, and it is approximately 1,200 kilometres in thickness, and it is radioactive. So those are the four parts that make up the structure of our Earth that we live on. So you have the crust, the mantle, the inner core, and the outer core, and they all have their distinct characteristics. And later in the lesson I'll show you a table that you need to complete, where you have to read through the booklet to make sure you understand the various components of each section. So, the countries and the continents of our Earth have not always been in the place that they are at present. Over millions of years, they have drifted. So originally, if you were to go back around 225 million years ago, there was what was known as a supercontinent, and it was called Pangaea. Now, Pangaea, as illustrated on the PowerPoint slide right here, which you all have at home, was almost a mishmash of all of the various continents of the Earth, all pushed together. Now, over millions and millions of years, the continents have drifted apart into their modern day positions. So over time, gradually they drifted further and further apart. Now, how do we know that this is true? Well, there are a couple pieces of evidence that point us to this conclusion. Firstly, wherever you go around the world, whether it be Western Europe, North America, Africa, or South America, you find the exact same types of rocks and fossils. They all share a similarity with one another. So the idea would be that because they are all so similar to one another, that they all had to have come from this particular continent of Pangaea, and they have merely drifted apart over time. The second piece of evidence, okay, and it is most obvious when you look at the map here and you look at Africa and South America, is that if you were to slide them together as a jigsaw piece or a jigsaw puzzle, they would fit rather nicely into one another. So if we can see, Pangaea starts out over here. Here is Africa, and here is South America. And over time, they've drifted further and further apart. So that nice jigsaw fit is what indicates to us that originally there was this supercontinent Pangaea. So, our final thing, these are the convection currents that I mentioned earlier in the video. So, the continents around us are still moving, albeit very, very slowly, and we will never be able to sort of view it in our own time and our own lifespan. So, the movement of the continents on the crust is the heat from the Earth's core is what's propelling it to occur. The heat in the mantle causes molten material to rise towards the crust. And as it does so, as the material rises upwards, it begins to cool, causing it to become very, very heavy, and then it sinks. This creates huge circular movements in the mantle called convection currents, because the sections on the crust sit on top of moving material, they too move. So there's this constant swirling beneath the Earth's surface, and this is what is causing all of the continents to move. So, what you've got to do in the geography booklet, you need to go to lesson 3, and you have 5 questions that you need to answer, and that is for today's lesson. So after you've done watching this video, read through the text. Feel free to come back to the video if you need to, but you need to answer all 5 questions and type them up or write them down in your booklet. One bit you also need to complete is this table here. Those of you that are doing this work on Microsoft Word, what you could do is go to this PowerPoint, copy and paste this table, and then begin to answer all of the sections. So for the crust, what material is it made of? Is it a solid or a liquid? What is the thickness? And the same for the mantle, the core, and both the inner and the outer core. All of the answers are all located within the booklet, so you just need to take your time to read through it. So, thank you very much, Year 7.